Welcome viewers, in this video we will see the details about Reciprocity Theorem. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The Reciprocity Theorem, one of the theorem available in circuit theory. First we will see the statement. In a linear bilateral network, a voltage source V in a branch gives rise to a current in another branch. The voltage source available in one branch that will give the rise of current in another branch. If V is applied in the second branch, the current in the first branch will be I. Suppose if we interchange the voltage from first branch to another branch, the current in another branch will be reflected in the first branch. That is the statement given by the reciprocity theorem. This V by I is called a transfer impedance or resistance. Right, now we'll see the diagram so that you're able to understand clearly. So this is the linear bilateral network is available. So the current, the voltage source available in the first branch. So there is a rise of current in the second branch, that is load end. This is the source end, load end. The reciprocity theorem, the statement is, if you transfer this voltage source from the source end to load end, that is that side, from this side to that side, the current in this side is reflected in the first branch. Right? That is a statement given in the reciprocity theorem. So this is the linear bilateral network. Voltage source available in the first branch, current is rise in the second branch. In this reciprocity theorem, if you interchange the voltage source from first branch to second branch, the current in the first branch will be reflected in second branch. So that is the thing. So this V by I is called a transfer impedance or the resistance. On changing the voltage source from branch 1 to branch 2, the current I in the branch 2 will appear in branch 1. So there is a statement, right? While interchanging the voltage, the current in that branch will be reflected in the first branch. Now we'll see the one solved problem. So in this solved problem, based on the reciprocity theorem, contain the DC circuit, the DC elements. For the circuit shown below, find I3 and verify the reciprocity theorem. So the circuit is given. In this circuit, we need to find the I3 current. So that we can treat that this is a load end. The source is available in the I1, available in the branch 1. Right? We can take this is a branch 3, this is branch 2. So our the problem given is we need to find the I3 value, current I3 value, and also we need to verify reciprocity theorem. So this is the first branch contain voltage source, second branch, this is the third branch current we need to find. So first we need to proceed with this circuit. We need to find what is the value of I3. In order to verify the reciprocity theorem, the voltage source available in the first branch should be transferred to the third branch. The current, so that the current in the third branch will reflect in the first branch. So that is the reciprocity theorem. So first we will take the circuit as it is, we will find I3 value. In the second step, we will transfer the voltage source from the branch 1 into branch 3, and we need to verify the current in the branch 3 will be reflected in branch 1. Right? So we will go to the step 1. We will proceed as it is in the circuit diagram. Say this is the loop 1, loop 2, loop 3. We are going to apply the KVL, Kirchhoff's voltage law, loop method by equation, by equation method. What is this equation? This is voltage matrix, current matrix. This is resistance matrix. V equal to I into R. Right? Voltage matrix, current matrix, and resistance matrix. What is this first one? This is R11. R11 means the resistance available in the loop 1. The sum of resistance available in the loop 1. Right? So 1 plus 10 plus 3. These three resistors are available in loop 1. So 1 plus 10 plus 3. So that is 14. What is this R12? The resistance available between loop 1 and loop 2. Commonly available between loop 1 and loop 2. So loop 1 and loop 2, the 10 ohm is available. Is commonly connected available between loop 1 and loop 2. So that is 10. What is this R13? The commonly resistor available between first loop and third loop. So this 3 ohm is connected between loop 1 and loop 2, this minus 3, right? Based on the current direction, it is given plus 10 or minus 10, right? If the both the currents are flowing in the same direction, then it is minus. Opposite direction means 10. See this current is flowing this direction, this also flowing in this direction, same direction, so plus 10. See here, this current is flowing downward, this current is flowing upward, so that minus 3, right? Same direction in positive, minus opposite direction means negative, right? So this is nothing but R21. 21 means the resistor commonly available between second and first loop, that is same thing, 10. This is R12, this is R21, so 10 ohm. What is this? Is R22, the total resistance available in the second loop. What are the resistors available? This 10 ohm, 2 ohm and 2 ohm. So 10 plus 2 plus 2, right? R22 is nothing but total resistance available in the second loop. What is this? This is R23, right? Available between second loop and third loop. This is second loop and this is third loop. So this 2 ohm is connected commonly between second loop and third loop. That's 2. See the current direction, this is going upward. This is also going upward. So plus 2, right? So this is anti-clockwise direction, going upward direction. This is all clockwise direction, also upward direction, right? This is R31, the commonly resistor available between third loop and first loop, that is minus 3. So very similar to this. This is R13, this is R31. Then this is R32, third loop and second loop. This is 2 ohm, very similar to this. This is R32, this is R23. And the final one, this is R33, the resistance available in the third loop. This is the third loop. What are the resistors available? 2 ohm, 3.7 ohm and this 3 ohm. So total resistor available between third loop is this one, right? So this is R11, total resistor in loop 1. R22, total resistor in second loop. R33, total resistor in third loop. This is R12, the common resistor available between first loop and second loop. Similarly, R13, between 1 and 3. Then R21, R23, this is R31, this is R32, commonly available between third and second loop. The current is I1, I2, I3. The voltage available in the first loop is 10 ohm. See the current direction, current is going from bottom to top, that is negative to positive, so that plus 10, rise in potential, right? So the current is going from top to bottom, that is 10 ohm, from negative terminal to positive terminal, so that plus 10, right? So in the second and third loop, there is no voltage source is available, that is 0, right? So after adding this, 1 plus 10 plus 3 is 14. Then 10 minus 3, 10. This is 14. This is 2. Minus 3, 2. By adding these 3, we'll get 6.375. So there is a small correction is this. This is the 1.75. This is not 3.75. This is 1.375. So that 1.75 plus 2 is 3.75 plus 3, 6.375. Right? So this is 1.75 ohm, not 3.75 ohm. So this value is correct, 6.375 by adding this. Now we got this value. This matrix is framed. R matrix, I matrix and the voltage matrix. Our aim is to find the I3 value. So that we will find a del value and del 3. So that I3 equal to del divided by del 3. So this is nothing but delta value. This is the delta value. So by replacing the third column with the voltage matrix will give delta 3. Right? If we replace first column delta 1, second column delta 2, third column delta 3. We need only I3, so we will find only delta 3, del and delta 3. I will go to that. So this is the delta value. 14, 10 minus 3, 10, 14, 2 minus 3, 2, 6.375. Right. Now we need to find the determinant. 14 into 6.375 minus 2 into 2 minus 10 into 6.35 minus 2 into minus 3. Then minus 3, 10 into 2 minus 14 into minus 3, right? So this determinant value is written. So after simplification we got 310, the delta value is 310, right? So now we'll go to the delta 3 because we need only I3 value, delta 3. So this third column is replaced by voltage matrix 10 0 0, right? The third column if we replace with voltage matrix it will give delta 3. Now we need to find the determinant value. 14 into 0 minus 0 into 2, then minus 10 into 10 into 0, 0 into minus 3, then plus 10, 10 into 2 minus 14 into minus 3, right? So many zeros are there, we can easily identify. So this delta 3 value is 620. After simplification we got 620. So that I3 equal to delta 3 by delta, 620 divided by 310, it is 2 amperes, right? The I3 value is 2 amperes. Now we need to verify with the reciprocity theorem. That is, now we need to transfer voltage source available in the first loop into third loop, and current in the third loop, this is the current in the third loop, will be reflected in first loop. That same 2 ampere is reflected in first loop, we need to verify. So we'll go to the step 2. So in the step 2, transfer the battery to the branch with 1.37 ohm resistor. The following circuit is obtained, right? The voltage source is transferred to third loop. The current through 1 ohm resistor is taken as I3. According to reciprocity theorem, the I3 must be 2 ampere. Let us calculate the value of I3, right? Now we are transfer the voltage source. Voltage source is now transferred. The voltage source available in the first loop is now transferred to the third loop according to the previous diagram. The current in this third loop should be reflected in the first loop according to previous diagram. After this modification we treated this is the loop 1, this is loop 2, this is loop 3. So the I3 should be 2 ampere because voltage source available is transferred to this loop. So the current available in the loop is reflected in this loop I3. So we need to verify I3 equal to 2 ampere. What we got in previous step, the I3 is 2 ampere. So here also the I3 should be 2 ampere. I3 is 2 ampere. Here also we need to get I3 equal to 2 ampere. Then it is the reciprocity theorem is verified. Now we will repeat the same process with the voltage with the matrix method. V equal to I into R. Voltage matrix, current matrix and resistance matrix, right? So this resistance matrix, this is the loop 1 now. Now it is loop 1. Previous diagram, this is loop 1, loop 2, loop 3. Now this is loop 1, loop 2, loop 3. The loops are interchanged, modified now. So the loop 1, the total resistor is 1.375 plus 2 plus 3. So the resistor available in the loop 1 is R11. Then R12, between 1 and 2, this 2 ohm is available. See the current direction. This is going down, this is going up. So minus 3. R13, resistor available between first loop and third loop, that is 3 ohm. This is current down, this is current up. So minus 3. Then this is R21, very similar to this. Then R22, the total resistor available in the second loop, 2 plus 10. Right? Then this R23, second loop and third loop, this 10 ohm is available. So current is also here, is going in a opposite direction. So minus 10. So otherwise, all the current directions are here, same direction we marked. So that other than diagonal, all elements are negative. In previous step, we marked the current direction in different current direction. But here all are uniform. All are flowing in a clockwise direction. In that case, if the all current directions are equal, other than diagonal, all other elements we can put negative. Right? Okay. Then we'll go to this R31. The common resistor between third loop and first loop. This is third loop, this is first loop, 3 ohm. Then R32. Common resistor between third loop and second loop. This 10 ohm. Then R33. The total resistor available in the third loop. 10 plus 3 plus 1. So 10 plus 3 plus 1. Right? So this is R11. Total resistor available in loop 1. R22 total resistor available in loop 2. R33 total resistor available in loop 3. All are positive. All others are negative because of same current direction. This is R12. Common resistor available between loop 1 and loop 2. Loop 1 and loop 2 is 2 ohm. Similarly, this is R13, R21, R23, R31, R32. Then the current is I1, I2, I3. Right? In the loop 1, 10 voltage is available, 10 voltage source. In loop 2 and loop 3, there is no voltage source, so it is 0. So after adding, we got 6.375 minus 2, minus 3, minus 2, 14, minus 10, minus 3, minus 10 and 14. Right? So this I1, I2, I3, 10, 0, 0. So this is voltage matrix, current matrix and resistance matrix. Now we need to find the I3 value. I3 is very similar to previous case, delta 3 by delta. So first we will find a delta. Replacing the third column with voltage matrix will give delta 3. From this we can find the I3. That should be 2 ampere. Right. So this delta value is available here, 6.375. So how to find that? 6.375, 14 into 14 minus 10 into minus 10 is written. Then minus 2, minus of minus 2. For the second case we are taking minus of minus 2. Then minus 2 into 14 minus 10 into minus 3. That is available here. Then minus 3. If we take minus 3, you have to multiply these two elements. Minus 2 into minus 10. Minus of 14 into minus 3. Right? It is all values are multiplied. I think we are able to understand the determinant. Determinant is easy. So after simplification, these are step by step, it is simplified. We got 310 value. So it is very similar to previous case also. Delta value is 310. But now we will replace the third column with the voltage matrix. So that we will get delta 3. So the third column is now replaced with voltage matrix 10, 0, 0. Right. Now we will take this 10 because these two elements are 0. We will take 10 alone. Right. In previous case we proceeded a normal procedure. Now we will take 10. If you take 10, you have to multiply these two. Minus 2 into minus 10. Minus of 14 into minus 3. These two elements are 0. So totally we will get 0 only. Right. So 10 into these two elements are multiplied minus these two elements are multiplied. After simplification we got 620. Delta 2 equal to 620. So from these two value we can find I3. I3 equal to delta 3 by delta. 620 divided by 310, 2 ampere. So the same value we got here also. When the voltage source is transferred from first loop to third loop, the current in the third loop reflected in the first loop, that is I3, is 2 ampere. So we calculated the I3 value and we verified the reciprocity theorem. In both the cases we got same value. While transferring the voltage source, the current is reflected in the third branch, that is 2 ampere. So hence reciprocity theorem is verified. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.